All right, let's take a look at section 2.6, ratio, proportion, and percent. All right, so as a reminder, a ratio, we can write it different ways. We can say use the word to B. We can use the colon A to B. We read that as A to B. Or we can write it as a fraction. In math, we generally choose the fraction method of writing. So, for example, I could say 2 to 3, or 2 to 3, or 2 over 3. It all means the same thing. Next. Maybe next. My screen. There we go. Write a ratio for each word phrase. When we write ratios, we do not need to include units in our answer. So if we have 3 weeks to 2 weeks, we would write that as 3 over 2. And the reason why we don't need to include our unit is because if we actually did have our unit, they would cancel out. So 3 over 2. Do not write it as a mixed number. Do not write it as a decimal. It has to be written as a fraction. Now, be careful here because this is hours and this is days. We have to make sure that we have the same unit. The units have to match, okay? So usually what we do is we take the bigger unit and convert it to the smaller unit. That's usually the easiest way to do it. So if we have 4 days, and again, we can do, I'm going to show you a method called unit analysis. You may have gotten this in a science class. So we know that 1 day, because I need to cancel the day, is equivalent to 24 hours. So with having the day on top and the day on the bottom, that allows me to cancel that unit day, and I end up with hours. So I would multiply these two fractions together. On the top, I have 4 times 24, which should be 96. Yep, 96, and I still have my unit hour, and on the bottom, I have 1 times 1, which is 1. So this gives me 96 hours. So 12 hours to 96 hours, we would write as 12 over 96. You can reduce these. This does reduce. And if I have a different calculator that does fractions, let's just do it the hard way. 2 goes into 12 6 times, 2 goes into 96 48 times, 6 goes into 6 1 time, and 8 times. So 1 over 8. There we go. Same thing, we're going to take the larger unit and convert it to the smaller unit. So if we have 2 yards, you guys know that there are 3 feet for every 1 yard. So this would give me 6 feet. So 12 feet to 6 feet. And you can do it the unit analysis way if you like. 12 to 6. Reduce it, but still write it as a fraction. You know that 6 goes into 12 2 times. You have to write it as 2 over 1. Do not leave your answer as 2. It needs to be 2 over 1. It's a ratio. I'm comparing 2 numbers, so I need both of them. Price per unit or the better buy. In a grocery store, I don't know if you've ever looked at the label on the shelves, and on the label is the big number, which is the actual price, and then in smaller numbers is what they call the unit price. Unit price allows us to compare 2 things that are, for example, of different sizes. So if you see a can of tomatoes, and there's a 12-ounce can of tomatoes for a certain price, and then there's a 20-ounce, maybe a 20 yeah, 20-ounce can of tomatoes for a different price, and you're trying to figure out which is more economical, yeah, more bang for your buck, you would compare the unit price, because just the price itself won't tell you if you're getting the best deal. So the way you do that, it's always the price per pound or the price per ounce or the price per whatever. So per means divide. So we're going to take the price per our ounces. And this we are going to use a decimal. So we are going to take 1.89 and we're going to divide it by 12. 1.89 divided by 12. And that will give us, we're going to round to the nearest thousandth. Okay. So remember, with decimals, this first is tenths, hundredths, thousandths. So we need 3 decimal places. So if we look at our calculator, it gives us this. We need 3 decimal places. So this is the last number that we're going to either keep or round up. And since this is 5, we're going to take the 7 and round it up. So $0.158 per ounce. Okay, do the same thing for each of these. So we have 279. And by the way, if you think this is one of those things that nobody ever does, I don't know about anybody else, but I actually compare the unit price all the time. And usually the larger size is the better buy, but not always. Sometimes they have a sale going on or whatever. I don't know. But we're going to round to 3 decimal places. So 0.116 per ounce. But for whatever reason, maybe the store is trying to trick you. I don't know. But sometimes the smaller container is actually the better buy. So it's always a good idea to check those unit price labels. And they're required by law to have them, because grocery stores actually did used to try and trick people into paying more so they would have more profit. All right, so 3 decimal places, 108. Okay. Now, I asked this question. Some students, for some reason, they misunderstand what the question is asking. And so what they will do is think more money is better, but in this case, it's money we are paying. So less money is better. Less is better when it comes to paying for something. So we're looking for the smallest per ounce, which would be the 36-ounce pancake syrup. Proportion. Okay, when we have a single ratio equal to a single ratio, it has to be a fraction equal to a fraction. You cannot have another number outside, so you can't have 1 plus 3/4 equal 15/20. It has to be just a fraction equal to a fraction. When you have that situation, we call it a proportion. And when you have proportions, you are going to solve it by what we call cross multiplication, which is different from multiplying across. If you have 2/3 times 1/5, you multiply across. If you have 2/3 equals x over 5, you multiply diagonally. So be careful here. Make sure that you know which situation you have. So if we want to check to see if a proportion is true, we are going to do cross multiplication. So we're going to take 21 and we're going to multiply times 45 and we're going to set that equal to, and put a little question mark here because we don't know, 62 times 15. So we're going to multiply the left side, 21 times 45, and we get 945. We still don't know. 62 times 15, and we get 930. So because these two numbers are not equal to each other, that means that these two ratios are not equal to each other, which makes this a false proportion. Same thing here, we're going to cross multiply. 13 times 119 equals 91 times 17. We don't know if these are equal to each other, so we're going to check by multiplying. And we have 1547 on the left. We still don't know if they're equal. 91 times 17 on the right. 1547. Because these numbers are equal to each other, that makes it a true proportion. But that's usually not what we do with proportions. Usually what we do with proportions is use them to solve equations. So we are going to cross multiply. So 42 times x is equal to 6 times 35. That should be a 3. So 42x is equal to 6 times 35, which is 210. And we're going to divide by our 42. And we get, divided by 42, we get 5. Now, some people can kind of, depending on the proportion, they can kind of do this in their head. If you notice, 6 times 7 gives me 42. So what times 7 gives me 35? The answer would be 5. 6 times 7 gives me 42. What times 7 gives me 35? And the answer would be 5. However, this only works when the numbers are really nice and whole and easy. Doesn't work if there's fractions or a situation like this. So we are going to cross multiply. Be careful because we have to multiply the 5 times all of this numerator, the x and the 6. The way to indicate that is to put it in parentheses. It's really important that you remember the parentheses. Otherwise, you will get the problem. You'll get it wrong. So you need to distribute. So 5x plus 30, this is times, not 22, so that would be 4. And subtract our 30. We get negative 26. Do not give me a decimal. And it does not reduce. So that would be your answer. Okay, this is a very typical proportion problem. Most of the time when we have proportions on a test, they are in the form of a word problem. Okay, so it's really helpful if we label the units. Okay, label the units. So we've got gallons and we've got dollars. It doesn't matter where you initially put the gallons and the dollars, as long as you are consistent on both sides. Okay, so if you initially put dollars on top and gallons on the bottom, on the left, then on the right, you would also have to put dollars over gallons. You will get the same answer either way you do it, but do not reverse these where you have gallons over dollars, dollars over gallons. That's the surest way to get the problem wrong. So we've got 12 gallons. That's a gallon. And we've got 49.68. That is a dollar. So that's going to go on the bottom. How much would, this is a gallon, so that's going to go on the top, 16.5 gallons. And we don't know the cost. So there's my X. Okay. Now, it's easier if we don't write the unit. 49.68, just to kind of clear it up just a little bit. But again, remember, If gallons go on top, money dollars have to go on the bottom, both sides. They have to match. So we are going to cross multiply, and let's go ahead and do 16 times 49.68. It would help if I could type it in correctly. All right, we get 8/1972, and we're going to divide by our 12, and we get 68/31. All right, this is probably one of the easiest word problems you're going to do in this class. Okay, percents. There are different ways to do percent problems. Because we're talking about proportions in this section, they want you to set it up as a proportion. Do remember, if I have a percent, in order to convert it to a decimal, you're going to take and move the decimal 2 places to the left. So that's equivalent to 0.50. Also remember that if I have a decimal point here, I do not need this end 0. 27% would be 0.27. But if I'm not converting it, if I want to write it as a fraction, I would write my 50 over 100, 50 over 100, okay? Or 27 over 100. So in this particular section, they want you to write it as a per 100, meaning over 100. Okay, so again, there's different ways to do these type of problems. They want you to set it up as a proportion. The way you set it up as a proportion is the amount over the base. Here's a hint, guys. Look for the word of. If it says the word of, then that one's going to be the base. So whatever number follows the word of, that one's going to be the base. And the percentage over 100. Okay, amount over base, x over 100. So amount over base, and remember this is the of word, is equal to x, whatever the percent is, over 100. Not necessarily going to be an x, by the way. X could be in any one of these places. All right, what is 3%? So that's going to be my 3 over 100 of 80. Okay, that's my base because it says of 80. Whatever number follows my word of is going to be my base. So the only one that's missing is x, and I cross multiply and divide by 100, and we get 2.4. Sorry, 2.4. All right, percent over 100 of what number? We don't know the of, we don't know the base, is 12. We're going to cross multiply and divide. And that's for sure not something I can do in my head. And it helps if it's on 1200 divided by 16, and we get 75. Okay, what percent of 75 is 90? We don't know the percent of 75. So that's going to be my base. Okay, cross multiply, 75x, 90, 2 more zeros because I'm multiplying by 100, divide by 75. Now, this should give us a decimal, or we actually, we're trying to find the percent. So make sure It's x is equal to 120. Okay, so remember you want to write that as a percent. Okay, so make sure you remember that percent symbol. Okay, of 3,800, what percent? So we don't know the percent. And the only other number left is 912. Whenever you multiply by 100, you add 2 zeros. Uh, 38. By the way, if I have 2 zeros on top, I can divide both of them by 100, like that. 2 zeros, 2 zeros, I can cancel those out. So right now I'm at 912 divided by 38. 912 divided by 38, and that would give me 24. Remember, I'm looking for the percent, so it's 24%. And there you go.